Okay, first of all, let no one say that slugs move slowly because this guy motors for a slug. This is a leopard slug, and I find them quite a lot in the garden. And this and an episode of Bones on TV got me thinking. They were talking about slugs like this creating an incredibly sticky kind of slime, like incredibly sticky kind of slime to the point that it could be used as glue. And I didn't believe it. I thought, come on, that must be Bones exaggerating for effect. But when you do pick them up, they have a really strange slime, and then when you wash your hands under the tap, it seems to become stickier and stickier. So you're left washing furiously, and even if when you add soap, it doesn't seem to, it makes it worse. So I thought, yeah, why is this? And then doing research online, found that there was an experiment from an American high school teacher, I think, or high school supplies or sort of resource based, and they showed you how you could extract slime in a hopefully non cruel way. And you can see I've got my little slugs who will be returned to the garden, to a corner of the garden where they won't do any damage, although they do move pretty quickly. Just to give you an idea of the size of this guy, here's my thumb. And what the site recommended doing anyway was scraping them along the dorsal, so the back area, gently with an ice block stick. But I'm wondering whether just a gloved hand might be enough. I don't want to really cause any pain if I can help it. Also, we've found that we've got a couple of females that look like to be protecting their eggs, so they won't be used for the experiment. Although a bit hard to see, but those orange clusters there, although it looks like the mothers, or one of them at least, has fled the coop. Just to give you an idea of how much slime they do produce, when I did a dorsal scrape, just a gentle sort of touch along their back, and that provokes a defensive reaction, and they give off a little bit more slime than they might do normally, and you end up with, it was kind of tacky and stretchy, and it did look a lot like the gelatin glue that I'd made the day before. But that's pretty much just from handling them. So I was able to get enough to do a little glue sample on paper, or slime sample, and also enough to put together these two blocks here as well. The reason why I was wearing gloves is because that slug slime can carry E. coli, or that's what they said in the American advice anyway. So if you were doing this experiment, it would be a really good idea to make sure that you're protected. And it's a tricky one. I don't know if I'd recommend that with children. I felt a little bit, thank you cat, rat bag, come here. I felt a little bit kind of squeamish, even though they're invertebrates. I felt a bit sort of strange extracting it, although it's possible that you could maybe just let them trail across paper or another surface to collect the slime. But yeah, I don't know if I do that one again. They didn't seem to be in pain, they didn't flinch away from it, like you'd expect with a snail. But yeah, interesting though. Okay, this paste is the cornflour and water. Not feeling quite positive about this one, although maybe it will surprise me. When I put some on my fingers to try, when I rubbed it together, it seemed to flake off quite easily, so it'll be interesting to see how it performs on wood. Fingers crossed. Okay, this was funny. This is the cornflour and sugar. They didn't actually specify how much water to add, but they said they wanted to make it to a paste. So I just had the old non-Newtonian slow motion stirring experience. However, 1 cup of water seems to work. That's cold water, and you stir until it's a paste. That seems to work quite well, although I had a bit of a panic when I put in about 3/4 of it, and I was going and I couldn't push through the mixture very easily, and had visions of just making oobleck. Okay, this is the end result of the sugar and cornflour with a tiny bit of vinegar added in at the end paste, and it was a lot like the cornflour and water paste when you started to cook it. It would start to catch as it heated up, and you could feel it fighting against your spoon. But this one, again, I'm looking at it and I'm feeling really sceptical. I put it between my 2 fingers, and it's still warm to be fair, but I just can't imagine this holding together paper, let alone 2 wooden blocks, so I'm curious. Bo's experiments used wheat flour, so that could be the secret, but yeah. I guess the benefit of the cornflour recipe is you end up with a heck of a lot of paste as opposed to milk glue, which makes a teeny tiny bit, but maybe it's like that old ad, 1 drop holds a ton, and that's our gelatin. It's interesting, the gelatin and milk, the proteiny, well, in my head I think protein, they both they look more gluey, the colour of them as well, so anyway, appearances can be deceiving. Have a little faith, science, faith, and yeah, and we'll see how they go. The next step will be to let them cool down and to test them out. Bo said that she tested hers on paper and used the clothes peg to pull them apart, so I'd like to try the same. I was just thinking about blocks in terms of being able to figure out how much force was used, because I wasn't sure how to measure paper, but yeah, so we'll see how we go there. Okay, this is the gelatin-based glue. It's with gelatin and skim milk. I've been mixing it quite hard for about maybe 1 or 2 minutes. It's still a little bit lumpy, and I'm wondering about adding a little bit more skim milk, but I think I might leave it and just use the recipe as it was wrote. But as you can see, it looks good and snotty and sticky, but this glue is one of those ones that apparently you need to warm gently before you use, so I keep that in mind when I'm doing my testing as well. Actually, as I'm washing my fingers, I've just been scraping the cup that I've had the gelatin mixture in, and it's really strange. It actually does feel like the slug slime when I try and wash it, although it comes off a lot more easily, so that's kind of unusual as well. Random thought as I'm doing the dishes, I just noticed there was a coating, as you do get when you've been heating milk, and it was all over the bottom of the milk, so I was starting to wonder what was happening to the milk structure itself as it was cooking. And then it got me thinking about the fact that I'll be using 2 pans, and whether or not Teflon coating or stainless steel pans are going to have an effect on what we're doing here as well. So that was interesting, the way the mind wanders when you're doing dishes, but also that would be a consideration, I guess, if you're doing experiments too, that you want to have a non-reactive surface, or be aware of the effects that will happen to your concoctions as you are mixing. Okay, this is how we'd make, or going to be part of how we make the milk glue or casein glue that Bo has shared the recipe for with me. Thanks very much, Bo. It's going to be interesting to see if we can get the same results. I'm using skim milk because I've read, you can see it looks sort of strangely green, because I've read that skim milk apparently is a little bit more effective than maybe other kinds of milk because it doesn't have fat molecules, or the fat basically doesn't get in the way of the process that's going to happen when you put the milk and the vinegar, together. So I've preloaded the glass with 2 tablespoons of vinegar, and I'm going to pour in 1/2 cup of skim milk. One-handed filming and pouring, not a good idea. Anyway, so I'll just hope for the best. And then we need to stir, so I'll pause there for some rapid stirring. Okay, I've been stirring the skim milk for about probably 3 to 4 minutes, and what I'm hoping to see are small lumps forming, but all I'm seeing is froth. So what I'm going to do is go slightly off-piste, and I'm going to modify Bo's recipe a little bit, because I think the fact that I'm using skim is probably having a bit to do with it as well, and try heating it gently, which is what I've seen on another recipe or another method, and it was the Nuffield Institute. So they recommend heating it until small lumps form. So I'll see how that one goes, and if this is an epic fail, I'll try using light milk or full fat milk. It's interesting actually sitting here stirring in a kitchen. It really brings it home or breaks it down for you about how much of, well, all of cooking is chemistry, if you like, as well, because you're relying on chemical changes to change the food into something you might want to eat. So, yeah, and to watch things really closely as well, to observe so closely when you're cooking. There's sort of so many things you take for granted. Better put my camera to one side so I can see what's happening here. Oh, I think we might have, oh, we have lumps. Gosh, it goes fast. Yikes. Okay, take it off the heat. Keep stirring constantly. Oh, drama llama. Okay. Right. Okay, I'm going to turn the heat off and keep stirring because I think we've got the curds and whey thing happening again. Yay! So with skim milk, it looks like heating is definitely worth it. Next stage of the process involves filtering it through either filter paper, or what I'm trying to do is what I've seen great chefs do, which is use like a chucks cloth. So I've washed that one out, so there's nothing behind it, hopefully, left in it. And cheese, say cheese. Next step will be to filter this through and then add baking soda. And I've read that by adding baking soda, that actually neutralises the mixture that you've made, or neutralises your glue. So I don't have access at the moment to pH strips, but what I thought I might try is testing the glue when I'll take a sample to school where we have pH strips, and then see whether my glue is actually neutral when I check it, or make another batch. Oh, that smells quite interesting. Okay, I better get ready to filter it out. Okay, really happy to report that chucks cloths are also not only a cook's best friend, but a scientist's best friend. They work really well as a filter. And my next step is to take a cup, we're going to put this into a cup and then add baking soda and stir. And apparently then it's supposed to start going sticky. However, if that doesn't work out, it looks like I made some pretty nice cheese. Okay, I've just added a 1/4 teaspoon of baking soda. I better concentrate on mixing, but it was interesting. As soon as I put it in, things started to break down straight away. So that was pretty... that made me feel optimistic anyway, because it didn't seem like it would be gluey at all. Okay, better concentrate now. Okay, this is the skim milk casein glue. And I feel like I'm a paid up member of Skeptics Anonymous, because I just put it on my fingers and it doesn't feel especially sticky. I have been mixing it until it's smooth, until it's a paste, so I'll keep mixing for a little bit longer, probably another half minute, and see if that seems to help. But I might try this one again, I think, with full fat milk or light blue, and see if that makes a difference. To be fair, it was a high-speed version of the one that Bo sent me. With the heat, it cut the preparation time by a lot, but I wonder if I've lost something by doing that, by speeding it up.